Welcome to another episode of the Cloud Native Show. APIs, serverless, and streaming apps are just a few types of the applications that we're going to build for cloud native apps. .NET Core is one of the languages built right here on campus. I'm going to go find Scott Hunter and talk to him about why .NET Core should be one of the languages that we should choose when building these types of applications. Let's go find him. Hey Scott.
Man, how's it going?
Good. I want to talk to you about using .NET Core for some cloud native apps.
Yeah, let's talk about that. Maybe even do a demo a little bit later on.
Awesome. All right. So, best-in-class languages used for cloud native apps. Why .NET Core?
.NET Core is interesting. If you look at the history of .NET was built in 2002, and it was primarily at that time built as a framework for building Windows applications.
Okay.
But a lot has changed since then.
Yeah.
The cloud's here now, and around 2013, we started envisioning a brand new .NET, and we changed our roots completely. We said, hey, let's be completely open source. Let's develop the entire thing in the open on GitHub. Let's have our roadmaps be public. Let the community see what's going on. We also said, let's take the technology and make it cross-platform. And for us, that means it runs on Windows, it runs on Linux, it runs on Mac. We support a variety of architectures, x86, x64, ARM32, ARM64, and we've learned a lot since 2002. Let's go take the lessons we learned and what we see in the cloud, and let's make a .NET that's actually designed to be cloud first.
All right, so cloud first, and you mentioned Linux, so we're talking containers, x64, obviously we went everywhere. Pi, we went everywhere.
Everywhere.
Okay.
We could easily be here with a Raspberry Pi on the table, and we could run a web app, live on that Pi if we wanted to.
Awesome. What were some of the challenges that you went at? What was the approach about? I got to run it on Linux. I got to run it in a container. I got to run it on a Pi. I mean, we're talking about a framework and language that was pretty bulky. Was just for Windows. What were some of the challenges and things that you had to get around?
Well, obviously the first challenge is we had to go find a version of .NET that actually knew how to run on something other than Windows.
Okay.
And so it might be surprising to people, but we actually had built a .NET called Silverlight, which could run on the Mac in the browser, and it could run on Linux. There was a port that the people who worked on Mono is an open source port of .NET Framework as well, but they had built a thing called Moonlight, which was a port of Silverlight that ran on Linux. But we went back and grabbed the Silverlight code because it was the closest code we had that had been kind of tested at production levels before cross-platform. So we started there, and then the next thing we said is, as I said, we had a lot of learnings over the years. As we had, .NET Framework had a configuration system in it, but it was very rigid, and it was hard to replace it on the fly. Various teams had found ways to take things like dependency injection and bolt them into the framework after the fact. And it's amazing if you go back in time and say, what if we put dependency injection in and configuration as first-class citizens? So imagine your cloud world. I'm developing locally, and I'm using a configuration system that just talks to my file system.
Right.
But as soon as I go and run into something like Kubernetes, I can actually go and replace the configuration system on the fly with configuration system that actually can understand the container that I'm in, Kubernetes,
right,
and read its configuration.
Right.
But your code doesn't have to change in the application. Another thing is logging. We never had great logging in the original .NET Framework. I don't know why. We kind of tacked some of it on after the fact, but this time, as we were thinking of, you're going to put these apps in the cloud, you need to have a great logging abstraction built in the framework. So as an app developer or a framework developer, You can put rich logging in your application, and if you want, you can even replace that logging with a third-party logging, but you're still using the same abstraction, so the code doesn't change at all.
So my logging was always, I was writing out to a file on disk. That's how I did my logging back in the day, and now we can just give it a log provider, have that dependency injection. I can write to a cloud and change that on the fly and not have to worry about recompiling my app.
I was going to say the big thing is the new configuration system, because it was designed to be cloudish.
Yeah.
You can actually go, our old configuration system, every time you change the config, the app restarted.
Yeah.
Now you can actually change the config while the app's running. So the example is your app's in the cloud, it's not doing so well, and you need more logging. So you just go and edit the config file, and suddenly, or go to the cloud setting you have for your particular application, and suddenly the log level just changes on the fly.
Right.
And so these are a lot of low-level abstraction-y kinds of things that we baked at the bottom of the framework this time, versus having them sit higher up in the framework. And everybody can take advantage of them. We put hooks in the framework. So it used to be that the framework was kind of generic. It just boots up and assumes it's running on Windows.
Right.
Now, whatever the app is running in, let's say you're running in Azure and you might be running an Azure App Service. Well, App Service can basically, there's hooks. So App Service can say, you're a .NET Core application and you're booting up. Let me inject some configuration for the diagnostics, so the diagnostic will actually write to the app service diagnostics.
All right.
They can do that on the fly, which means as a developer, I don't have to think about, am I running in Kubernetes? Am I running in Azure App Service? I can just publish my app to all those different places, and because the framework and the host can be aware of each other, they can light those things up on the fly.
We also took approach from what I understand now is that now that we are kind of opting into all of these different, we took a middleware approach, right? So that, and speak to that if you will, about how now we're able to kind of take the pieces that we need. Those are either, not everything's in the box, right? So the old way was everything just came in a big box. It was very monolith type of approach. Talk about maybe some of the middleware options that we have. You talked about configuration and logging, but what's some of the other stuff? I mean, do we have routing and things like that gives us those capabilities?
That's a great point. If I go back in time and think again of where we started, .NET Framework was the kitchen sink approach. Basically, everything is chunked in there. It's on by default. You get all this great stuff, which was great. If you didn't really know web programming, it was a great place to learn and get started because everything just kind of worked and was turned on by default.
Right.
But let's say you're a bank and you're trying to build a really high performance microservice. Well, you don't want all that stuff. And so what we did in .NET Core is, number one, everything is very in your face. It's code first, meaning that when you look at the file, the startup file, we have a file called startup.cs, and inside of it you'll see all the middlewares that'll be hooked up. And as you said, some of those will be things like configuration, some of those will be logging, some of those will be routing, and you can decide to turn serving static files, for example, HTTPS support, automatically redirecting to HTTPS. Those are all in your face. So if you go, I don't need those three things. Hey, I'm going to turn off serving static files, I'm going to turn off HTTPS, I'm going to turn off routing. You can now dial those things as you want.
Right.
You can also write your own.
Sure.
So there's a whole ecosystem where the community's gone and built their own middlewares to do a variety of things. Like we don't have SOAP support out of the box, but there is a SOAP middleware for .NET Core that you can actually inject into the application, and you've got great SOAP support. Another example of a middleware is we all build APIs today. What if you want open API for your API? Well, there's plenty of middlewares you can inject that will actually give you an open API endpoint and generate the swagger on the fly for you for that. So those are examples of making the framework super pluggable and composable.
By pulling all these pieces out, it sounds like, first I start with maybe the dump truck approach, and now I'm down to maybe the Yugo, but does that affect my performance and my size? I mean, where are we at with that? With my deployable executables or my files? I mean, what are we looking at there?
Today, if you put the entire .NET Core on a machine, you're looking at somewhere between 60 and 70 megs to put .NET Core on the machine, which is not super big.
Yeah.
I would still like it to be smaller. And so .NET Core 3, the next version we're going to ship, we're going to introduce for the first time linking, where you'll be able to basically link out the pieces of .NET Core that you're not using as part of your application. So, if you're not using XML parsing, then we can link that away. And so that's the first step for this. We want to get to a point where we can at some point give you some kind of single exe AOT-ish kind of thing, AOT ahead of time compile. Right. And a lot of that will come in the 3-wave. The 3-wave will give you the single exe, and it will give you some of the linking. But we have steps to go where we can actually make our own frameworks easier to link to get the apps even smaller and smaller. But we envision getting ourselves down at some point to like a 30 or 40 meg, total on disk size for say a microservice.
Sure. So talking about microservices and knowing kind of some of the ecosystem around that, being Kubernetes and Linux and things like that, was that the motivation behind getting .NET to run on Linux and these other devices, was to get into that microservice world, that cloud-first world?
There was a couple motivations. Number one, what we had seen was Linux being embraced by the cloud heavily. And we wanted .NET to be a great place to build cloud applications, which means we had to go embrace Linux as well. And so that's where the Linux side of it really comes down to play. It's kind of funny, as a framework developer, I don't really think that most people that are writing a microservice think of the actual host OS anymore.
Right.
As you get into the container space, I think you stay within the framework you're in, whether it's Go, whether it's Node, whether it's .NET Core. You kind of stay in that space, and whether you're running on Windows or Linux doesn't matter. But making ourselves work on Linux was a key thing. And a great example of this is, you asked, why .NET? One of the things that we are really proud about is the Tech and Power benchmark. The Tech and Power benchmark is a third-party independent benchmark, kind of an open source project, where people submit their code to this benchmark, and then once a quarter, they'll run the benchmark on a variety of hardware. And if you look, .NET does pretty dang good in that benchmark. Yeah. You can write, a microservice without a lot of framework, or you can use our bigger framework, which gives you a lot more convenience, a lot more productivity. And if you look at the benchmark, like the plain text, both our bare metal and our higher level frameworks do very well over there. But that benchmark is just kind of showing raw, how fast can you shove stuff down a pipe. Right. We get to the point right now we're running like 4 million requests a second, which is pretty dang good. Yeah. That'll saturate a 10 gigabyte network card before we run out of CPU. The cooler demo to me is there's another demo there called Fortunes. And the Fortunes demo is serving HTML, it's talking to a database, it's doing the things that I would expect a real world application to do.
Sure.
And you're going to, once again, you'll find us up towards the top of that as well. We're typically in the top 10, if not higher, in both of those benchmarks. And this is a thing the team has embraced, is trying to make performance a key component of .NET Core. To the point, we've even added language features. There's a language feature called span, which allows you to map types on top of memory, so you don't have to double memory, right, as stuff comes in. So we're actually modifying the framework on the fly as we think of performance. And so we want to make .NET one of the fastest frameworks for building any microservice cloud application.
Okay. Talking about anywhere, anything for any purpose, and it's, I think sometimes we get the question of why .NET? What do you do best? And we do a lot of things best. You talked about we can run on a Pi, we can write a microservice. I know in .NET 3.0 we have the worker templates coming, right? So it doesn't use HTTP, but maybe it's just that process that runs and does work. That's our microservice type of templates. I've spoken with the team about how we're using that. We've got gRPC coming, we've got all those things. But before we jump into that, what's our basic microservice template look like? What's a hello world look like for us?
Yeah, so we can show that if we want to show that.
Sure.
So first off, to your point, before we get into the code, when you think of, one of the things we struggle with is when you think of .NET, or people outside of Microsoft think of .NET, they might think of ASP.NET.
Yeah.
That has been the web framework that we've actually had since the beginning of .NET. Mm-hmm. And as we mentioned earlier, when that framework was first built, it was meant, there was not a lot of web in 2002. And so we were actually, as a team, trying to get desktop developers to be able to build web apps very easily. And so a lot of convenience, a lot of stuff done for you automatically. Drag and drop,
Right.
you know, a lot of that kind of stuff. In some ways, you have a reputation for that historically, you think of ASP.NET, you think of web, you think of HTML, and you think of those things. But the reality is .NET is not, or ASP.NET and .NET Core are not just about that. You can also build very lightweight, high-performance microservices, as we said, for that Tech Empower benchmark. And so what I've got on the screen here is a simple microservice. And what you're going to see here is I say that I need to use routing, because we need a route request into this thing.
Right.
I'm going to use endpoints. And so what that means is I will then basically give it a path. In this case, I just said the root.
Okay.
But I could also specify parameters there in that. And if the request matches that, whatever you put there, it can then call this function. And in this case, I inline the function. You know, normally I would probably put that somewhere else. And you can see that in what?
I don't know.
10 lines?
10 lines,
10
yeah.
lines, we wrote a microservice.
And on top of that, we're also taking advantage of asynchronous inline here. So we've got async.
We're doing
async
async here as well. And you can't see it because we're not using it, but this application supports logging. This application supports the configuration model.
Right.
So you are getting some of those conveniences as well, because we put those in the root of all the applications.
Right.
But the point we're trying to really show here is, don't think of .NET, especially .NET Core and ASP.NET Core, as this heavy bloated framework. You can go as bare metal as you want to as full featured as you want. And that I think is the benefit of our stack. You might have one API that you need to be really, really high performance. And so you can write it this way.
Sure.
You might want to have another API where the performance doesn't have to be as good, and you want us to automatically map the parameters to types and do all that kind of stuff for you. And we give you the best of both worlds. You can basically dial from bare metal all the way up to full convenience at your choice. And in the past, we kind of forced that on you, and no longer. So if we just run this, it's not going to be super exciting. It's going to launch the browser. And you know, we served the Hello World app here.
Sure.
Something else to talk about here is you're going to notice I'm not in Visual Studio.
Yeah.
You know, the old .NET
VS Code
required a
runs
large,
Yeah.
full-featured IDE. Another tenet of .NET Core was we work in all editors. There's an open source project called OmniSharp, which provides the syntax highlighting and that kind of stuff, the language services inside of VS Code. It also works with other editors, so you're not locked to even VS Code. But we have an IDE from the Mac. We have an IDE for Windows. We have VS Code, which runs on Windows, Mac, and Linux.
And we have a great command line experience as well, too.
Yeah, exactly, and we have a great command line experience. If I wanted to, I could easily just go to the command prompt. So here we are in the command prompt, and if I want, I can just do .NET run. It'll launch the application. But I can also just say .NET new. All the applications can be built right from command line. .NET build, .NET watch run, if I actually want to stay in the IDE and just keep refreshing the app, restarting the app every time I change code.
Right.
So we're fully supported all the way from a rich IDE down to command line. And that is a tenet of .NET Core as well, is we actually build at command line first. So the idea is everything starts at command line, and then we wrap that in a rich IDE. So once again, you can dial that however you want. You can go to the command line all the way to the full-featured IDE,
right,
and you get the same level of support.
So if I like to live in Vim, in the command line, on Linux, on Ubuntu, I'm good to go.
For you.
Everything
yes.
to go, right? Awesome.
Yeah.
So .NET Core 3, we mentioned worker templates, gRPC, and what are the other improvements we're making for cloud native? I mean, you talked about this is our simple 10-line, 9-line app that we're doing. I know that we've got some things like HTTP client factory and a ton of things that we've added in the framework. What do we got coming down the pipe for 3.0?
Big stuff in 3.0 is the worker template, which you described. One of the things that we try to do is we try to give our customers templates to get you started for some of the common types of applications. So worker service is, I need to have a long-running process, a service. Worker service is pretty cool because it gives you that template ID for building that type of application. Imagine you want to listen to a queue and do something when a message goes into a queue. That's your typical, in a lot of cases, microservice-y things. You can add a single NuGet package to that and turn that into a Windows service. You can add another NuGet package to that and turn it into a systemd daemon. So whether you're on Windows or Linux, you get awesome first-class support for that.
Right.
I think that's a pretty cool aspect of that. gRPC. gRPC is all about doing RPCs. We already have great support in .NET Core for doing RESTful web APIs, but a lot of customers really want to have contract-based RPC, and it is kind of tightly bound.
Right.
They're aware of that. Historically, we've had things like WCF and .NET remoting, but in the open source world, we want to embrace open source. So gRPC is an open source project that we're contributing to.
Right.
And the benefit of that means you can build your gRPC service in .NET, and you can call it from Node, or call it from Java, or call it from Go.
Right.
At the same way, you can actually build a gRPC service in Go and call it from .NET. So we're trying to play well in the open source ecosystem with gRPC, making it easy to go both directions.
Sure. Yeah, that's and again, those are all those in cloud type of technologies we're looking to do, and some of the things we didn't get into, we'll get into later in the show series is .NET is, like you said, not just APIs. It's not just the web front ends. I mean, we're using .NET in serverless. We're using it in IoT. We're using it everywhere where we're creating these big distributed applications, right? Is there anything else that if somebody says, why .NET? Why would I want to use this? And this thing, I know we've got .NET 5 coming. We've got a lot of things in the pipe. I know we're constantly revving this. We're not tied to the Visual Studio release like we had been in the past.
We're not tied to Visual Studio. We're not tied to Windows. Other things we didn't talk about, .NET Core 3 has a bunch of new awesome diagnostic tools for running on, let's say, Linux.
Yeah.
We basically have first-class logging, first-class diagnostics, first-class ability to take dumps of your application, all built into .NET Core 3. We didn't talk about it, but we did talk about REST APIs.
Yeah.
So we have a bunch of support for the Open API initiative as part of the .NET Core 3 wave as well, where we can easily let you generate the Swagger for your API, and we can build the client side for you as well. So it makes it very easy to call a REST API.
Self-documented code.
Yeah. There's about a 20 to 30% performance improvement in .NET Core 3 over .NET Core 2.2.
Nice.
One of the cool ones we talked about was that plain text. We can do serving of static files and stuff like that with 0 allocations now.
Nice.
Which is pretty cool. As you mentioned, as you go forward into like the .NET 5 wave, that's the wave after .NET Core 3, that's when you're going to start seeing us shrink the size of those apps down even further. The single exe is in .NET Core 3, but we'll have a much better flavor of single exe in .NET 5.
Awesome.
So lots of exciting stuff coming in the future, and I can't wait to see what we do on this show as we actually go and hopefully build some real microservices and get them running in Kubernetes.
Yeah, that'd be great. Awesome. I think I appreciate you taking the time and talking to us about .NET Core and building cloud native apps. We're going to definitely dive deeper as we start to build some apps and looking at the stuff that's coming, the stuff that's here now. When we talked about speed, performance, build stuff anywhere with this tech. And again, appreciate time.
Yeah, and I just want to add one more thing. To close, you asked why.
Yeah.
So performance, we already have performance. We have an awesome first-class language, C#, which just got better as part of .NET Core 3 with C# 8, a bunch of new features added. And productivity. The real thing that we try to do is give you tools around the tech that make it easy to put your apps in the cloud and stuff like that. So I think one of the things that some of the other tech, it's like, here's the tech and go for it.
Right.
And we try to say you can do that, or if you use one of our fancy IDEs, we'll actually make it as simple as right-click publish, or we'll make it as simple to say right-click, add to CI/CD, and our goal is to actually make it easier for you to get your apps into those environments.
First-class languages, first-class tools?
Yeah.
All right, that's where we're at. Awesome. That was another episode of a Cloud Native Show. We appreciate you taking the time to watch us with Scott Hunter and talking about Cloud Native apps. Be sure to visit aka.ms/Cloud Native Show for future episodes. Thanks for joining us. Thanks for watching the Cloud Native Show. Be sure to subscribe, watch for a future episode, and especially our streaming shows on Twitch, where we build apps based on the conversations had right here. We'll see you next time.